Welcome to the next module for the Programming Bootcamp, and in this module we'll be talking about loops and lists. So both loops and lists are very important tools you need to know as a programmer. We will start with lists. So a list is like a variable, except it can hold many different items. In Python, these items can be different data types. They can be integers or strings. This is not the case in all languages though. And the way we actually create a list is using square brackets. So we put items in the list and we separate them by commas in square brackets. So we have many different methods we can use on a list. So when you have a list, when you type in the dot after a list, you'll get a list of methods you can use from Pycharm. You can also use control and space to get these methods. And note too that a string is kind of like a list as well. It has many of the same methods that a list has. It's not exactly the same as a list though, but you can consider it as a list of characters. So some of the methods that we have, you can append to a list, which adds an item to the end of a list. We can insert at any position into a list, and you can sort a list. And also you can find the number of items in a list using len, and that will work on a list and a string as well. So to actually access an item in a list, we use the name of the list, we use square brackets, and then its position in the list. So for Python, each item has a position in the list. It starts at position 0 and increases from there. In Python too, you can also use negative indices into a list, where -1 would be the last thing in a list. This is not the case with all languages though. The other thing we can do with lists is to use list slicing. So when you slice a list, you slice out a range of values in that list, and you use the name of the list, the position of the first thing you want, and the position of the last thing you want, separated by a colon. If you leave out any of these, it will just default to the start or the end of the list. So you can see on the right hand side here where we have left out the start value. It takes everything up until the third item in the list, but it is an exclusive range, so it won't include the actual third item in the list. So for this case here, we get position 0, position 1, position 2, which is A, B, C, but not at position 3. It's up until position 3. So you can also have an optional third parameter when using list slicing, which comes after another colon. Usually when we slice a list, it'll take every element in the list in the range that you give it. If you change that to a 2 here after the second colon, you would get every second element, and if it was a 3, it would be every third element, etc. And in this case, negative here, we're taking it in reverse due to the negative indices being used. So again, that is very much a Python thing, using negative indices in a list. So not all languages will allow you to do that. So before we have a look at loops, we will check out some coding with lists. So to create a list, you can populate it yourself with the values you want. And you can also create an empty list and use append, which we'll do here. So we'll create an empty list. So an empty list is just with square brackets. And then you can use the append function to add values. So you can add as many values as you want. We'll just populate a list with 3 numbers, 1, 2, 3. So if we print out a list, you'll see it as a list with the square brackets in the console and everything in the order that you created it in. So you can see down here we have 1, 2, 3 in the square brackets. So we can access elements in our list. So we'll use the A list here. So accessing elements in a list, we use square brackets and then the position of the thing we want. So at position 0, we would expect to see A. This is the first thing in the list. So not assign that yet. So we'll print that first. And I'm going to comment out that. So we can see that A is being printed. We asked for the first thing in the list, which is what we got. So we can also use here the inbuilt length function. We can say, so to get the last thing in the list, that would be at the length of the list minus 1, because we start at position 0. So this, in this case, will return E to us. Due to using negative indices, we can also use -1 in Python to get the last thing in the list. So if we run that, we would get E returned again. So we can also change values of a list. We can reassign values of a list. So if we wanted to change A that was in our list to a G, we can just do that as the same way we access a list to display it. We can just reset it using list access. And if I print out my list after doing that, you'll see that A should now be a G in our list. Yep, and we can also sort a list as well, which is something that you often need to do. Dot sort, and now when we print it out, we should have B, C, D, E, G this time, instead of G being at the beginning. So you have various other methods you can use. I'll just show you quickly. If we have the name of a list and then we do dot, you can see that in Pycharm you get the list of all of the methods that you can actually use. Again, it really depends on your use case and your program as to what you'll need to do with your lists. And the other thing we saw was list slicing, which I'll demonstrate here. So if we do, again, our A list, we start at position 1, we go up to position 3. I'm just going to comment out my other print statements. So our A list was this list up here. So we would start at position 1, so we should get B up until position 3, which is where our D is, but not including. So we should get B and C returned. So when we run our code, we can see that we've sliced out B and C from our list. The other option is to use a fourth parameter. So let's take the thing from position 1 to the end of the list. So I'll leave out the middle parameter, and we'll take every second item. So in this case, we should just get B and D, and it will end. So when we run that, we can see B and D. So I mentioned that a string is like a list as well. So we can use many of the same methods, and we can access things in a string like we would a list. So if we wanted the first thing in our string, the first letter in our string, or first character in our string, we can just access it like we would a list. But importantly, we can't actually change things in our string. So a string is said to be immutable, which means we can't directly change items in our string, whereas a list is mutable. We can change items in our list. So we saw before that we changed A that was in our list to a G. If we tried to do a similar thing to our string and turn our programming bootcamp into a programming bootcamp, when we run that code now, we're going to get an error because we can't actually, it doesn't support item assignment. We can't do that to a string. But there's other ways we can work around that. There's string methods, but you can use slicing like we've seen. So what we could say is a string equals B if we wanted to turn it into programming bootcamp. And then we can use list slicing for the rest of our string. And so we want from position 1 to the end of our list. So we're creating a new string. That should be string, not lists. So instead of reassigning an item in our string, which we can't do, we've created a new string in place of it. So when we run that now, we should get programming bootcamp, like we were trying to do. So we'll have a look at some loops now. So loops are something you have to use all the time when programming. So essentially they repeat a block of code a number of times. They have other use cases for creating sequences of numbers. It really does depend on your program. And the way we can think about a loop is by the control of a loop variable. So a loop variable is like any other variable. And in a loop, you need to do 3 things with the loop variable. You need to initialize it, so set it to its initial value. you need to set the terminating condition on it, the thing that will end the loop. So when this evaluates to false, your loop will end. And you also need to change the loop variable so that eventually the terminating condition will be met. So if we have a look at the program on the right hand side, we can see that we initialize our loop variable. Our loop variable is just called I. In this case, we're going to set it initially to 0. We're going to run all of this code in our while loop while this condition is true. So as long as I is less than 10, we're going to run all of our code. The third thing we need to do is to change the loop variable. We're going to increase it by 1. So what will happen here, the first time your code runs, we'll have I equals 0. Before anything's done, a check is first done. So we'll check, is I less than 10? That will evaluate to true. Then I will be printed. We change I from 0 to 1. Then we go back to the check again, and we check and say, is I less than 10? It's 1. Yes, it is. So our code will run. Change it to 2. Keep doing the check, and so on and so on. So provided your I value is always less than 10, your code will run. When it gets to 10, we will check here, is I less than 10? In that case, it will evaluate to false, and that will be the thing that ends your loop, and then your code will continue with the rest of your program. So there are two kinds of loops. There's while loops and there's for loops. So we'll first have a look at while loops. So the general use case for a while loop is for when we don't know how many times we want our loop to run. And the while loop is the more general of the loops. It can do every situation you can use a while loop. So again, if we have a look on the right hand side, we can see that in this case, our loop variable is a string. It doesn't have to be an integer or a number. So a person is our loop variable. The condition that must be met for our loop to run is that it must not be the empty string. So provided we don't have the empty string, this code will continually run. And then we're changing the loop variable here by getting some more user input. So this will continually prompt for user input until nothing is entered. When nothing is entered, then your loop will end. So you can see what the program does. It will continually print out the names, and then when the loop ends, you'll be here in your code, and we have more code to run, and it's going to print out the actual list of people because we were appending them as we actually got the person's name. So that's a while loop. A for loop can be used when we actually know how many times our loop should run for. So a for loop in Python makes use of what we call the range function. So the syntax is to say for variable name, which is I in these examples, but you could use any variable name in range and then run your code. So range can take in 3 different values. So when it has one value, it is the end value. So it will always start at 0. If you omit the initializing of the loop variable, it's always initialized to 0. The change amount, if you leave it out, is always 1. So you can see here in the second one that you can actually use the loop variable in your loops, and this is quite common to do in programming. This final one, you can see that we're starting at 10, we're going up until 20, but not including 20, and we're increasing by 2, so you get multiples of 2 from 10 up until 20. So for loops are probably more handy of a loop to use, and you'll probably use for loops more often, but there's some things that you just have to use a while loop for. It really does depend on your program. So the other thing that you'll see too, using the for loop notation, for lists and for strings, actually have an inbuilt iterator, which will loop through for you. So you can leave out the range function. So you can see that animals is a list of animals. We can just say for variable name, in this case we're saying animal in animals. We will get every item in our list, and you can do the same for strings as well. So you can get every letter in your string. Infinite loops can happen with while loops. In Python, it's very hard to, or maybe impossible, to actually create one in a for loop, but in a while loop, they can quite easily happen. So sometimes you'll want your while loops to be infinite for event checking is a common example in code, but in general, most of your programs, you want your while loops to end. So you have to be careful when using a while loop not to create an infinite loop, and we'll have a look at some loops to see how they work and how infinite loops can sometimes happen. So I have the while loop that we had in our slides. So we were starting at I equals 0. We're going to run our while loop while I is less than 10. So when we run this code, we're going to get 0 up until 9 printed out. So you can change any of these values to change your loop. So we could start at -2. So this time we would have from -2 instead of from 0. We could change the condition on our loop to run for a longer time, and we can change the change amount. So you have to be careful too. You can change if we're checking less than or greater than, or for equality. So if we were checking for greater than, in this case, we would first say initializing to I equals -2. When we got to this point in our code, it would say, is I greater than 10? In this case, it isn't. So our loop wouldn't even run in that case, and we're not going to get any output displayed. So this can be a bug in your code quite easily. You expect your loop to run, but because you've done an incorrect terminating condition, your loop hasn't even run at all, and you don't see an error, you just see no output. So you have to be very careful when using a while loop. So I'm going to steal list code. So we can use a while loop to actually loop through a list as well. So we could say our loop variable we'll call index. We'll set it to be position 0. We're going to say while index is less than the length of our list. We're just going to print out our list in this case. So we're going to use the index. So we would say a list at index, and then we have to make sure we actually change our loop variable so it loops through all of our list and will display all of our list. So when I run our code, we'll get A, B, C, D, E displayed. So you can do that with a while loop, as I mentioned from the slides, and this is the way you would probably do it. Given that lists have an inbuilt iterator for this, you could say for item in a list, this is the quickest way to do it, and then you could just print out item in that case. So we'll get A to E printed out twice. And then we could also use a for loop to loop through our list. So we could say for index in range, and in this case we want all of our lists. So we say length of a list, and then this is in a similar style to our while loop where we would have to actually use list access to print out everything. So you can really use a matter of preference with code, and depends on also what your actual circumstances are in your program and what you're using your loop for. So we'll have a look at some for loops. So for loops have using the range function. If we wanted to do something a set amount of times, you would probably use a for loop to do that, or not. Of programming. So if we wanted to display that 5 times, we see all our programming 5 times. So for loops are probably the quicker loop to use when you know what you're doing, you know the amount of iterations you need in your loop. So the other style in using range is with 2 parameters, so we'll use numbers here. So we can start at 2 up until 10, and we'll print out I, our loop variable. So we can see from 2 up until 9 printed out. So the other thing we can do using range is using 3 parameters. So in this style we can do a reverse loop. So we can start at 10, go up until not including -1, so down to 0. And if we want to go backwards, we would say -1 as our change amount. And then we can print out I. So you have various options with your loops. It does come down to a matter of preference and a matter of practice, and also a matter of circumstance in your code. So I mentioned about infinite loops. generally not desired in your code, and they can easily happen though, and it will put a stop to all of the rest of your code running. So we're going to remove changing of our loop variable from our first while loop. I need to make sure this actually runs to start with. Now, because I is initially set to -2 and it's never changed, this check will always evaluate to true. So this code will always run and it will just clog up your console with -2s in this case and chew through your memory. So there is, as I mentioned, some circumstances where you'll want to have a while loop that is infinite. This is usually in event checking with user interfaces, and in most coding circumstances, you need to take care when using a while loop to make sure that it starts like you intend and that it also eventually ends. So we'll go back to our slides, finish module, having a look at a flowchart. So flowcharts are really good to explain all of these coding concepts that you're learning. So they're particularly good for loops because we can visualize what's happening in our code. So you can see that a for loop and a while loop are very similar. The first thing they do is they check the condition. This condition happens to be false, then the code in your loop will never run. We will go down the follow the false and we'd end our loop. And as long as your condition evaluates to true, your code will run. The main difference being that your for loop will always change your loop variable before the check, whereas a while loop, this is not the case, and you have to ensure that happens as a programmer. So you should have enough information now to attempt section 3 in your group exercises, and we will see you all in the next module.